Good morning. My name is Iman Barmaki and I work for Kensa Contracting. We are here today at Chadwell St Mary in Thurrock, where we're retrofitting 3 tower blocks with ground source heat pumps connected to a shared ground array. The residents in these blocks all have electric storage heaters and are currently experiencing really high heating and hot water bills. With the energy price cap having been lifted and energy prices going up, many residents are finding themselves in fuel poverty. What we're doing here is replacing those storage heaters with ground source heat pump connected to a shared ground array. This system is much more efficient, it's quiet in operation, and often we see a 50% or more saving in heating bills and a 70% reduction in carbon emissions. For us, it's really important to engage with our residents that we're working with to demonstrate how the system works, and it can often be challenging to demonstrate that with technology when it's not visualized. So what we've done here is put a mock-up room in place where we can demonstrate how the ground array is installed, how the pipework is connected to the block, and this is the layout that people will have within their properties: a shoebox heat pump at the bottom, Sunamp heat battery, and all the controls that go along with it. Each property will have their own thermostat and programmer, so they can have full control of how they run the heating system. The radiators will be fitted with thermostatic radiator valves, so they can turn individual radiators up or down depending on the rooms that they're using. And overall, what we're trying to do is give them much more comfort, and by providing affordable warmth, these residents will be lifted not only out of fuel poverty, but hopefully will have better health as well.
Here we are at the first stage of the installation process with the drilling of the boreholes to provide the energy to the ground source heat pumps. So here we've got a Komatsu 602 drilling rig drilling hole number 70 on the site so far. We've got 109 boreholes to drill on the site to provide all of the energy we need to heat all of the flats within the 3 tower blocks here at Chadwell St Mary. So the drilling technique we're using here is what we call mud flush. We're just inserting the rods here at the moment, ready to start drilling again today. We connect each of the rods together, and that's all connected to the mud cleaning equipment. We basically pump the water from there down through the drilling rods to the bottom of the drill head, where we drill the rock as we go. That water then pushes the cuttings, the risings that we've just drilled from the hole up the outside of the hole and into the box at the top here. That muddy water is then pumped away through a set of filters, take all the cuttings out, and then we circulate the same water through to retain the drilling process. So each of the boreholes is drilled to an average of 258 meters. Once the borehole's been drilled to depth, it's then time to insert the borehole probe. We've got a continuous length of 45mm HDB pipework with a fusion weld connection at the bottom. That probe is lowered into the hole. It's meter marked, so we know that we've got the probe all the way to the bottom. Once that probe's installed and pressure tested, we then backfill with a bentonite grout. So we just backfill the hole that we've drilled with that compound to make sure that we get thermal conductivity in between the pipe and the ground around it. We drill each hole in around 2 days and move the rig around the site, and keeping all the central mud cleaning equipment in the same place. For this particular site, we've actually got 3 rigs in operation, trying to move around the site as quickly as possible so we can give the car parking back to the residents. At this stage, we're installing the riser pipework to connect the ground arrays into the individual apartments. So here in the corner, we've got the risers that come up through each floor. We have a fusion weld tee at the top here, where we tee off to provide the flow and return to serve the laterals, which then serve all of the individual heat pumps on this floor. So to allow us to do this work, we have to do a structural survey of each floor to detect where the structural reinforcement is for the floor up through the tower block. In this particular block, the rebar, the reinforcement, was actually pretty inconsistent across the floor, which made it challenging to provide a route up for the pipe work all the way through the building. So what we've done is we've put some reinforcing bars on each floor just to maintain the structural integrity, which has allowed us to drill a straight riser all the way up through each individual floor. And the next stage will be to lag it, so we'll put a vapor barrier insulation on all of the pipe work, and then finally we'll box that all in, hide it away so it's looking nice when we finish. So from the risers, we have the main lateral pipework that comes through into the corridors here. We've converted into carbon steel pipework with press fit that runs at high level all the way through the corridors into each individual apartment. Once we've completed all the pipe work, we'll fully lag all of this pipe work again to prevent condensation and from any exposed pipe work. And once that work's complete, we'll fire stop in between any of the entry points into the dwellings, but also between any of the entry points through the corridors. Once we've teed off into each individual apartment, we come into the five-way valve arrangement here. What this allows us to do through this set of valves is to close the two valves into the apartment and actually circulate flow from here all the way down through the ground array. That allows us to flow and pressure test the whole of that circuit ahead of the internal installation, and we'll do that for each set of laterals and on each floor through the building. At that point, once we're ready to undertake the installation, we can isolate the risers. The heat pumps will be installed and connections into the flow and returns here. We can then open these three valves and flow and pressure test from the heat pump through this circuit. Once that's done and we know that the heat pump's ready to set to run and commission, and because we've got flow, we'll basically open these four valves, close the one in the middle, and that's the system ready to run and circulate flow from the heat pump all the way down through the laterals, risers, and then into the boreholes.
My name's Diane Barr and I've been here 16 years, and yeah, the heating it's a big expense. It's at the moment, because obviously the rates have gone up, it's about £70 a week. That's just the heating, that's not doing washing or drying or anything like that. So yeah, and it's going to make a big difference, no heating. It's been bad, like windows get wet and we wipe them every morning, you know, so kitchen's freezing, let's put the cooker on. Yeah, it's going to make a hell of a difference, being able to put it on when I want to and turn it off and have a bit of heat in the bedrooms without having to put extras on, you know what I mean, because storage heat is so overnight, so if you forget to put it on, you've got no heat next day. Really pleased, about time, I could say, yeah.
I'm Colin Bridges, and I've lived there 13 years, and the heating is unbelievable, you know what I mean? Gets me down sometimes, going and putting money on the electric and all this. I mean, I think this should have been sorted out a long time ago. I mean, 13 years I've had to live cold, in the coldness. I don't want to go down that road with the heating because it's literally a joke. I mean, when it's done, I'll be happy. I'll be an happy person. We literally can't afford to put the heating on, the heaters on, because it just swallowed me money. It'll make a lot of difference to my life. It will make a lot of difference. Oh, much warmer. Be lovely. Be lovely.
Hello, I'm Matthew Trewella. I'm the Chief Executive Officer of the Kensa Group. Although this project is in social housing, it can act as a blueprint for how we decarbonise heating across the UK. Shared ground arrays and networked heat pumps can be funded completely separately, so you can put the infrastructure in the ground as a utility funded concept, and then properties can connect one by one as they're ready. So we can displace the gas grid in an orderly fashion in exactly the same way that the gas grid was put in and displace coal heating. So right here, all the properties are going to connect on day one, and that's why it's easier to deploy this in social housing right now. But fast forward even just a few years, and we think by 2028, this type of approach will be being rolled out across cities and towns across the UK.
And I believe that's the end of the tour. Matt, if we can move on to the next slide. So I hope that was informative and helped you to kind of visualize an installation of this scale. As Matt